Hello everyone, am I audible and visible? Let me know, then we'll start. Am I audible and visible? I think so. Okay, fine. So, hello everyone, myself Dr. Deepthi Karya. I'm an MD PhD Physiology and I'm your educator for physiology. So today we'll discuss about properties of cardiac muscle. Okay. Before starting the class, I would like to announce you that you will get all my notes in soft copy as well as in hard copy. For soft copy, you have to download the application Vesalius and you have to subscribe for the same. And for hard copy, you can order my book, that is Physiology Notes. You can order on Flipkart as well as Amazon. Link for all that is given in the description box. Okay, as well as you can join us on our WhatsApp group or WhatsApp number, that is 78638 22668. So you can join this WhatsApp number as well as link for the WhatsApp number, that is also given in the description box. Fine. Now let us start with the properties of cardiac muscle. We have enumerated all the properties. Properties are excitability. These properties are divided into two groups. One, that is electrical properties, and second, they are mechanical properties. Electrical properties are excitability, automaticity, rhythmicity, conductivity. And mechanical properties are contractility, all or none law, refractory period, and this staircase effect. Fine. Now, just a minute. I just wanna put my mobile on flight mode so it will not harass us. Okay, fine. Now, still. Okay, fine. So let us start with the property. We have discussed in our last class with the property of excitability. Now today we'll discuss about the property automaticity or autorhythmicity. Now what is this property? Heart muscle, they have property of generation of their own impulse at their own constant rhythmic interval, and this property is known as autorhythmicity. Okay, what is the importance of autorhythmicity? Because of autorhythmicity, heart continues to beat if we are cutting the nerve supply of the heart. Okay, we are providing nutrition, oxygen, nutrition, and pH. Heart can continue to beat. Okay, so heart has specialized pacemaker tissue and it has the function of automaticity or autorhythmicity. Okay, now what are the characteristics of pacemaker tissue? This pacemaker tissues, they have unstable resting membrane potential. Okay, why unstable resting membrane potential? That is because of change in membrane permeability. Change in membrane permeability of this pacemaker tissue. Okay, therefore membrane potential will not be steady. Instead, you can see here that is unstable. Okay, and the slow depolarization that is found between action potential, and this slow depolarization is known as pre-potential or pacemaker potentials. Now, what are the characteristics of pacemaker potential? This property of the spontaneous pre-potential, and that is followed by action potential, that is responsible for automaticity or autorhythmicity. You can see here resting membrane potential of SA node that is pacemaker of the heart, and resting membrane potential for the SA node that is minus 55 to minus 60 millivolt, instead of resting membrane potential of the ventricular muscle that is minus 90 millivolt. Okay, and at this minus 55 millivolt, you can say that this fast sodium channels, they are inactivated. Why are they inactivated? Because of closure of the inactivation gate. Okay, only you can say that sodium calcium channels, they get activated, and this sodium calcium channel, they cause generation of the action potential. This action potential generated, that is slow to develop. Now, you can see here characteristic of pacemaker tissue. Here, this is the diagram. It shows this pacemaker potential. That is because of slow depolarization. Okay, membrane potential, because of slow depolarization, it reaches to threshold. This is the threshold potential. You can see minus 40 millivolt. Okay, once it reaches to threshold potential, that results in generation of action potential. Okay, So you can say that slow rising in the resting membrane potential in between the action potential, that is responsible for the generation of action potential, and this slow rising in the membrane potential, that is known as, this is known as pacemaker potentials or pre-potentials. Okay, and due to this unique feature in pacemaker tissue, there is self-generation of rhythmic impulses, and this property is known as autorhythmicity. Okay, now pacemaker tissues, they have unique feature as we have discussed. Here there is leakage of sodium ions. You can see here at number 1, there are funny sodium channels here. Okay, so leakage of sodium ions, and it causes slow diffusion of sodium ions. Sodium ions, they enter. Okay, and because of diffusion of sodium ions inside the assay node fiber, that takes place in the resting state. What happens, because you can see here, this is the cell, and when sodium ions, positive ions, they enter inside, what happens, the membrane potential becomes less negative, so it becomes minus 55 millivolt, and there is slow depolarization forms initial part, this one, this part of the pacemaker potential, and at this point there are opening of transient calcium channel. You can see here, this is 2 transient calcium channels, they open, and because of this opening of transient calcium channel, now this potential reaches to threshold minus 40 millivolt. Okay, and that is responsible for remaining part of the depolarization. Okay, why these channels are known as funny channels? Because of their special current in the heart, because these are funny channel because it has effects opposite to most of the heart current. Okay, these channels, they are this that is a mixed sodium potassium inward current, which is activated by hyperpolarization, and it is modulated by autonomic nervous system. Now another thing is this pre-potentials. This pre-potentials, they are due to slow decrease in the potassium efflux also. Here, this is one another characteristic is slow decrease in the potassium efflux, and permeability of other ions, they remain constant. Decrease in the potassium efflux and transient increase in the calcium influx, and that completes the pre-potential. Okay, so you can see here, initially funny sodium channels are there, then transient calcium channels are open, and then long lasting calcium channels, they are open. Okay, when membrane potential reaches to threshold here, then your long lasting calcium channels, L type of channels, they get opened up. Okay, and at the end of depolarization, now your potassium channels, they open, and because of exit of potassium ions, there is repolarization. Okay, now when the natural pacemaker is destroyed, what happened next? Pacemaker would be your, suppose SA node is destroyed, then your AV node becomes the pacemaker, but the rate of generation of rhythm is slow as compared to SA node. This is about 40 to 60 beats per minute, and if it is also destroyed, then Purkinje fibers, their rate is about 40 beats per minute. Okay, now, next is certain agents. They affect the heart rate. They alter the heart rate by changing the slope of pre-potential. You can see here this one. Parasympathetic, they make the slope less steep, and sympathetic, they make the slope more steep. Okay. Now you can see here. What is vagal tone? Vagal tone means, you can see vagus nerve, that is parasympathetic nerve, which innervates SA node. So SA node is innervated by right vagus nerve. Okay, and here the neurotransmitter release, that is acetylcholine, and acetylcholine increases permeability of the SA nodal fibers for potassium ion. So what happens when potassium ion permeability increases? There is hyperpolarization, and therefore firing rate decreases, and therefore impulse generation rate also decreases, so heart rate also decreases here because of the vagus nerve, and this is known as vagal tone. Now how can it be proven? Suppose if you have experimental heart, or in frog or any other animal, if we are cutting vagus as well as sympathetic supply both to the heart, what happens? We get the intrinsic rate of the heart. And what is the intrinsic rate? That is 100 to 110 beats per minute. Means our intrinsic rate without any nerve supply, that is 100 to 110 beats per minute. So vagus nerve, when it is stimulated, this nerve supply increases. Sorry, vagus nerve, when it is stimulated, then the heart rate decreases. So our heart is under the effect of vagal tone. Fine. Now, what is the role of autonomic nervous system in regulating heart rate? Parasympathetic, when they are stimulated, heart rate decreases. That is known as negative chronotropic effect. Okay, as well as there is decrease in the excitability. That is known as the negative excitability. That is negative bathmotropic effect, and decrease in the conduction. This is known as negative dromotropic effect. So strong parasympathetic stimulation blocks the transmission of impulses for few seconds. Okay. Now, another, that is effect of sympathetic stimulation. When sympathetic nerves are stimulated, what happens? The neurotransmitter norepinephrine is released, and this norepinephrine has positive chronotropic effect, positive bathmotropic effect, positive dromotropic effect. Okay, chronotropic increase heart rate, dromotropic, that is conductivity, bathmotropic, that is excitability. Okay, so this is the effect of parasympathetic stimulation. Now, action potential in the other cardiac muscle, like in the ventricular muscle. In the ventricular muscle, you can see that resting membrane potential is minus 85 to 90 millivolt. Okay, and on stimulation, then it reaches to plus 20 millivolt. Okay, and after reaching to the peak, now there is a plateau phase, this one, and which is followed by fall in the membrane potential, that is repolarization. And the presence of plateau in the action potential causes ventricular contraction to last about 15 times as compared to more longer as compared to skeletal muscle. Okay, then what are the characteristics of conducting system? Conducting system consists of modified type of cardiac muscle cells. These cells are small rounded cells with very less organelle, and they are connected by gap junctions. Pacemaker tissues, they are the part of the heart from which rhythmic impulses are generated, and they are our SA node, AV node, bundle of his, then Purkinje fibers. These all are our conducting as well as pacemaker tissue. Now, rate of production of impulses in the different parts, that is here, I will just, that is for SA node, this rate of production, that is 70 to 80 beats per minute. AV node 40 to 60 beats per minute. Atrial muscle also 40 to 60 beats per minute, and ventricular muscle is 20 to 40 beats per minute. Okay, now, so this is again same thing, pacemaker potential we have already discussed. I am not going in much detail. Sodium calcium channel and depolarization and pre-potentials. Okay, fine. So this is all about today's topic, autorhythmicity. Thank you all. If you wish to get all my notes, they are available in soft copy as well as hard copy. For soft copy, you have to download the application Vesalius, and for hard copy, you have to order my book, that is Physiology Notes. You can join us on WhatsApp number, that is 78638 Okay, link for all that is given in the description box. Thanks for watching. If you like my video, you can like it, you can share with all your friends, and you can subscribe our channel. Thank you so much.